Hello and welcome. In this video, I'm going to complete a series of tasks on mpls on OcNOS devices. First of all, let's take a look at the task. Then I'm going to explain the topology and then some theory behind this, and then we are going to get to the configuration. So the task says configure interiors mpls option A in this diagram and ensure connectivity of the customers. For now, I have a company here, ABC. This company asks for connectivity to the other branch on the other side using mpls from us. We are OENet solution in this case, and we have mpls network enabled inside our network, and we don't have any connection to New York. So what we do is we are going to ask one of our peers to provide this service for us, and then we can just go through that. Our peer here, of course, has mpls enabled inside that, and then we are going to provide this back-to-back mpls service for ABC. ABC is going to be able to reach to its other branch on New York. Now, why would we do that? Why would we go with such a configuration? Why would we want to have interiors mpls, or what we call it a carrier supporting carrier service? Let's say that there is limitations for the service provider. Service providers cannot have global presence. That's going to be super expensive. They have some limitations, and this is going to cause them to use their peers to enable this kind of a connection. And the other thing is, let's say there is a service provider which is able to do this for us, for example this one, and ABC has a connection to that. But the problem might be ABC wants to have some kind of a redundancy, which it means that ABC wants to connect through another service provider have mpls connection. In that case, for example, this service provider that of course doesn't have a global presence, but it has a significant service that ABC wants to use. So we really want to do that, and in this case, of course, we have to go with CSC, or carrier supporting carrier, or AS MPLS, whatever the name is you want to give it, and then you should enable the service for the customer. Now, what are the options? How can we do that, and what are the benefits and drawbacks of each one of those options? As a matter of fact, there are three different options. In the first option, I'm just assuming that there is no second service provider, and this is me. I'm going to receive everything through VRF interface, then I'm going to send it to the other IBGP neighbor, which is enabled VPN v4 address family. And then I'm going to just send it here, and that is my customer again. So this is a VRF, and this is another VRF, and I assume that this is directly connected to ABC. Now the thing is, Elegance should do the same exact thing. So it just receives the information through this VRF, then sends it to this VRF inside. It has this VPN v4 connectivity, then MPLS network, exactly as we have here. So everything seems to be as if the other one doesn't exist and we are directly connected to our customer. Or you can say we are assuming that the other service provider is the customer itself, not a service provider. So this is option A. In option B, though, things are going to be a little better, or maybe more complex. In this, what we are going to do is to enable a VPN v4 connectivity between these two. And this is going to, reduce the number of links that we have between these two service provider. In option A, we have to have an interface or a sub-interface here for each VRF. This means that for each one of these VRFs that we have, we need to configure an interface. We need to configure redistribution maybe here, in case we are not using BGP under this VRF, as a matter of fact. And we need to manage everything for separate customers separately, which means that extra administrative burden for us. But here, we only have one VPN v4 connection between these two on option B. And of course, again, we do not really need to know more than how we can reach to each other. But what about option C? In option C, things are going to be a little better and more efficient. In this, let's say, for example, I have a rod reflector here and rod reflector here, and these rod reflectors, of course, are VPN v4 rod reflectors, and we are going to establish a session between these two. The thing is, when we do this, we have to know how to reach to each other, because as you can see, there is 1 hop at least, 2 hop, and 3 hop at least between me and the destination. And I need to create eBGP multi-hop in here, and I need to know how to go to here. I need to know some kind of internal infrastructure IP addressing information from the other side. This means that security is not so good in this kind of a connection. Let's take a look at this chart. This chart I have downloaded from Orhan Ergun website. That's a very nice comparison chart between the 3 options here, and then see what we have. So in option A, scalability is the least. What I mean is, when I want to configure a new customer, I have to go through all of those configurations again. And of course, not completely, but we have to do some kind of redistribution or create a BGP session under that VRF. This is what I'm going to do, and I'm going to show you how. Security is the most, because we don't really know anything about the other service providers' infrastructure, VRF configuration, IP addressing configuration. All of them are going to be kept secure. Flexibility is very flexible, but of course it is very hard to achieve. You're going to see that everything should be done. Staff experience, of course, is not going to be so hard to not going to be so hard to train, because they already know about L3 VPN, and this is going to be just an extra step that they need to take. There is no MPLS between the carriers. Complexity is not so much. BGP label unicast is not used, and the resources, of course, is going to be a lot, because even the PEs between the 2 service providers have to have all the prefixes in their routing table and forwarding table at the same time. And also, this means that control plane and data plane is going to be utilized, and we have to have resources for them. Convergence is going to be super slow, because each one of those VRFs and sessions have to converge. Troubleshooting is not going to be so hard. Redistribution, like I said, we need to have, unless we have BGP for that specific address family. And the scenario, of course, is used in different places. Option B, like I said, is not going to be that limited as option A. It's going to be a little more scalable. Secure is okay. Like I said, they just need to know how to reach to the other side, not internal network. And what we need to have is, let's say, implementation is a little hard, and understanding is going to be a little hard. Option C is the best. Option B is going to be kind of a middle ground between option A and option C. Option C is one of those that people really do not want to configure. Like I said, because of the security restrictions that might be there. But there is a very good scenario in which option C is going to fit the best, and that is mergers and acquisitions. In case, for example, a service provider buys another one, they trust each other, and there is no problem in exposing their internal infrastructure to the other one. In this case, of course, it's going to be the best one. So option C is going to have kind of an ASPR plus LDP connectivity. And ASPR, what I mean by that is the PEs connecting the 2 service providers to each other. Okay, so let's go to our lab and start the configuration from here. A lot of configuration have been done before, so routers, internal routers here, they have an IGP and also MPLS and LDP enabled for them. The same goes for Elegant. Also IP addressing for this ABC network is already done. So let's go to R1, and what I'm going to do is to show run router BGP. As you can see, there is a connectivity using VPN v4 to router 3, which is here. And what I need to do is to configure the VRFs now. The thing is, in option A, you do not really have to have the same VRF name, VRF route distinguishers, or VRF route targets inside the same these two service providers. Each one of them can have their own configuration separately. They don't need to even know what kind of configuration the other side has done. All they need to know is how they are going to connect to each other. That's all. And I'm going to do this. Ethernet 3 is the interface between router 3 and router 4. This is the link that I'm going to use. For ABC, you should really go with sub-interfaces, but because of some limitations that I have on virtual machine environment, as I am using right now, I want to go with separate interfaces for each one of these customers. So if I just go to router 3 here and say show run interface ETH3, there is no configuration for now. Later I'm going to add an IP address using a VRF actually. So I'm not going to do it right now because I'm going to lose it later. Okay, let's go back to router 1 and configure the VRFs. So I'm going to say configure terminal, and I'm going to say IP VRF, and let's say it is called ABC1. And then I'm going to configure a route distinguisher of 77 or whatever number that you want to have, and a route target of 77 or whatever route target that you want to configure. This interface ETH7 is going to be under this VRF. So I'm going to say interface ETH7. IP address is going to be 10.171/24. But before this, I need to say IP VRF forwarding ABC1. And let's commit this and see if this is going to retain the IP address. IP address should have been added after VRF, but that's okay, no problem. Okay, next thing that I want to do is to create kind of a routing protocol between router 7 and router 1. You can have BGP, you can have OSPF or ISIS, or you can go with the static routes. In my case, of course, I'm going to go with the OSPF. So what I'm going to say is router OSPF, and let's say 2, and the VRF is ABC1, because I want to put this under VRF ABC1. The network is going to be 0000/0 or /32 based on your choice. Doesn't really matter because both of them are going to work. And net is going to be this one, and maybe router ID is going to be 1111. That's okay, no problem. And then this is going to include this Ethernet 7, and there is going to be an OSPF neighborship between router 1 and router 7, of course router 1 under VRF ABC. Now what I need to do is to receive the prefixes from ABC, and then I'm going to redistribute it into BGP, VPN, V4. So what I'm going to, and also vice versa. So I'm going to receive the prefixes on BGP, and then I'm going to send it to OSPF, VRF, ABC1. So here under OSPF, I'm going to say redistribute BGP, and that's it. Hit enter. Then I'm going to go to router BGP 100. I need to create an address family for this VRF. So address family IPv4, and VRF is going to be ABC1. I'm going to redistribute this OSPF 2 here. And let's say I'm going to redistribute connected network as well, because later I will need this. So I'm going to say commit. And most of the configuration is almost done. Okay, so let's just show the configuration so that we can see what we have done so far. And also I need to copy some of the configuration to the other side. So we have created a VRF. This VRF should go to router 3 inside my own service provider here. So I have just created this one. Then after creating this VRF, we have of course LDP configuration, loopback configuration, everything has been done before, MPLS configuration, but now we have this interface ETH7 under IPVRF forwarding. In my case on router 3 is going to assume that, let's say that elegant is not there. There is no elegant here. ABC is connected to Ethernet 3, so I'm going to do this. I'm going to go to this interface, and interface ETH3. I'm going to say IPVRF forwarding is going to be ABC1. Then IP address, of course, going to be applied. Let's say 10.10.134.3/24. Okay, so I'm going to commit this part so far. Next thing, I want to check the connectivity that I have to my customer on router 3. Like I said, the connectivity is going to be with Elegant, but let's say that we are connecting with ABC directly. Assuming that we are using BGP in this case, I don't need redistribution. But if I use OSPF, for example, then I will need redistribution. Most likely, you're going to use BGP between the two service providers. So, what I need to do is to create this BGP connection under the VRF itself. And that is one of the drawbacks, because for each one of the VRFs, you have to create a neighborship between these two, which is kind of a bummer. But let's go to router 3 and do this. On router 3, I'm going to go to router BGP 100. I'm going to create an address family IPv4 for VRF ABC1. And let's say that I'm going to say my neighbor is 10.10.134.4, which is in remote AS 200. And I'm going to activate it. And then I need to redistribute the connected link here because I need it for just making sure that I'm not going to have a black hole on the path from the source to the destination. So you see, I have created this under this VRF, which means that for other VRFs, I have to create the same thing, or I need to use, for example, OSPF or ISIS. Then I need to redistribute from the major BGP into them, and then from them into the major BGP, so that we have this kind of a configuration done. And the rest of the configuration, that's it. Nothing more than that. Just make sure that router 7 and router 1 have a connectivity. So if I just go to router 7, on router 7, I'm going to say show run router OSPF. I don't have any OSPF configuration. I'm going to say router OSPF, let's say 1, for example. And router ID is going to be something like 7777. And the network is going to be 0000/0 area 0. And then I'm going to commit this. Now, if I say do show IP OSPF neighbor, the adjacency is going to be there after some time, as you can see it here. Okay, let's save everything. On router 1, let's save everything. On router 3, let's save everything. Here it says that uncommitted. Let's commit this. And then save everything. Okay, so far router 3 should have received some prefixes from router 7. So if I just say check show IP BGP VPN v4 all, you can see that I am receiving 7777 from router 7 on router 3. Okay, let's do the configuration from the other side. Now assume that there is no OENS solutions. We have just Elegant, and Ethernet 3 is directly connected to ABC on the other side. So let's go to router 8, router 6, and start the configuration. On router 6, I'm going to say IPVRF, and let's say this is called ABC2, not ABC1. See, the VRF name could be separate, route distinguisher could be separate, anything could be different. So I'm going to say RD is not 77, but 88. Route target could be 88. For both, of course. 88. Then the interface connected to the other side is interface ETH7. So I'm going to say interface ETH7. IPVRF forwarding is going to be ABC2. IP address is going to be 10.686/24. That's the IP address that I'm attaching to here. Let me just bring it this way so that you can see everything on the other side better. Okay, so let's commit the configuration so far. And now I need to create an OSPF process because I am using OSPF process between ABC and here. So what I'm going to say, rather OSPF2, OSPF1 is used for internal network, so another procedure, and the VRF is going to be ABC2. Under this, I would say router ID is 6666, and the network is going to be 0000/0 or /32, whatever that you want to put there, and area 0. And then we are going to have an adjacency after committing. But the thing is, I need to redistribute from BGP. Redistribute BGP is going to be here configured. Let's go to router BGP then. Under router BGP 200, I need to have an address family IPv4 for VRF ABC2. Then I need to redistribute connected maybe, and also redistribute OSPF2 here as well, because I want to send all the prefixes into BGP to other side, which is my router 4. Then I need to say commit. Okay, so that I have done this, let's go to router 8 and do the configuration here really quick. Show run router OSPF, nothing is configured. I'm going to say router OSPF whatever number, router ID is going to be whatever, and the network is going to be everything, /0 area 0. Then I'm going to say commit, and this part is done. Okay, let's go to router 4. Router 4 is the other PE for elegant. Router 4 is going to receive the prefixes and it's going to send it into Ethernet 3. So router 4 is going to go to configuration. On router 6, I'm going to copy some of the configuration to the other side. For example, this VRF configuration goes to here. Then under interface ETH3, I'm going to say IPVRF forwarding is going to be ABC2 and IP address of 10.1.10.10.1.34 4/24 is going to be applied to this. Let's commit this part. I'm just committing these so that if I have any problem, I can just do it super fast. Let me just move it a little bit to the left so that you can see router 4 better. Then what I need to do is to create this BGP connection between the two service provider, and let's say between the customer and service provider, because like I said, just assume that this is not connected, but we have just used BGP between these two. So what I'm going to say is router BGP 200 under this address family IPv4 for VRF ABC2. I'm going to say redistribute connected, which is necessary because I want to have these prefixes in my VRF for just making sure that there is going to be connectivity. And also my neighbor is going to be 10.10.134.3, which is in remote AS 100. And I'm going to activate this as well. And that is going to be almost everything that we need to have here. So if I just commit, everything should be perfect and done. So I'm going to say save. Let's show the running configuration to make sure that we have lost nothing. So we have configured the VRF. We configured the interface under VRF. And then we configured this VRF under address family. And then we sent the prefixes to the other side. So far on router 4, if I just say show IP BGP VPN v4 all, you can see that I am receiving the prefixes from router 8 from the right side. And that is for here. Let's just do it one more time. Okay, so if I just say show IP BGP VPN v4 all summary, these are the connections that we have right now. We need to wait for this to come up. So far it hasn't come up. So let's just see if we can just ping 10, 10, 134, 4, and that should be under VRF ABC2. So the ping is not going through. Let me see why. Show IP interface brief says that so the IP address is configured incorrectly on Ethernet cell. So that should be 4. I have pressed 7. So if I just say show run interface ETH3, okay, I need to correct this. Configure terminal, and that should be 4. And then commit and end and save everything. Now if I just try to do the ping, here is the ping goes through, and if I just say show this, you can see that the adjacency is there, and also I need to have the prefixes. So you see that I am receiving prefixes from the other side, I am receiving prefixes from my side, and now I should see that customers have the prefixes. So if I just go to router 8, for example, on the right, and say show IP route, you can see that I have received the prefixes from 7777, and also this is the link between the two devices, and this is my link to, let's say, the other side of the link to the service provider, and this is the loopback interface from the other side. The final test is going to check the connectivity. And for that, what I'm going to do before doing anything, I want to just capture this Ethernet tree so that we can see the traffic. So I just go to here, capture ETH3, and open Wireshark for that. Here is Wireshark. Let me just minimize this one. And remind me later, I don't want the update right now. I'm going to start sending a ping from router 8 to router 7. So I'm going to say ping 7777. I'm going to source it from 8888 and hit enter, and then stop the ping because that's enough. So you can see that the connectivity is there, and the packets that go through here, this one for example, has this naked, as a matter of fact, IP. There is no label on that, and like I said, that is as if we are directly connected to the customer and just we are sending the naked packet to the other side. No label on that and nothing. So anyway, connectivity is there, configuration is there. Let's take a final look at the configuration just to see what we have done, and I'm going to just say stop without saving. Going back to here, I'm going to say show run. Let me say enable on all of the devices, and then say show run on all the devices so we can just check the configuration. On router 8 and router 7, all we need to have is just a connection to the service provider. Whatever routing protocol or static route we are going to use, that's okay. The major configuration goes on PEs. 2 of the PEs facing the customer are 1 and 6. Let's go to 6, for example. What we have here is configuration of the VRF. Doesn't have to be the same on both service providers. Going down, you can see that LDP is configured for internal MPLS configuration. We have MPLS configured for internal network. And then we have this interface which is facing the customer, configured under this VRF that we have configured. Also, because we are connecting to customer using OSPF, then we have just created an OSPF process here. And of course, redistribution of BGP VPNv4 into BGP, IPv4 for this specific VRF is there. So if I just go to BGP, you can see that this is the VPNv4 connection to IBGP PE. That's okay, nothing special about that. But this is the VPN, this is the VRF IPv4 VRF address family that we have created for that customer. The most interesting part of the configuration goes between these two service providers. For each one of the VRFs that we have here, we have to create a sub-interface at least. And sub-interface, of course, is going to be the most common one. And if I just check that on router 4, for example, you can see that I have created an adjacency with my customer-like service provider. I use BGP, but you can just go with any type of other routing protocol. If you go with OSPF, then you have to have redistribution here as well. If you have ISIS between these two, again, redistribution. But BGP maybe is the simplest configuration because we don't need to have redistribution. Then we have this VRF. And the thing is, like I said, if I just go to router 4 and say show IP, BGP, VPN, V4, all, and hit enter, you can see that in my control plane, I have all the prefixes for my customer. And if I say show IP route VRF all, you can see that in my routing table, I have to have all the customers' prefixes. So this is, although you can see that there are not so much prefixes here, only 4 in this case, but assuming that my customer has hundreds of prefixes, thousands of prefixes, and I have hundreds of customers then you can see that this is going to unnecessarily be huge, and that's going to have a lot of resources used in this kind of a configuration. The other side is exactly very similar to this one, and that's it. So we just did configuration of Inter-AS MPLS option 1. I hope this has been informative for you, and see you in next videos.